Hi, welcome everyone for the third part of the exploratory data analysis series. So we'll be continuing with our analysis and going even deeper into the understanding the data set, the Pokemon data set itself. Okay, so let's get started. So as you can see, we'll be talking about something called box plots. I've written some details to save time when we start. Okay. I'll explain what this means and what is the relevance of the same. Okay. Uh, so we have this data set, as we know, with various features like type 1, type 2, total HP attack, defense, special attack, special defense, speed, etc. So supposedly we want to understand the distribution of the various numeric variables like total HP attack, defense, etc. Okay. So how can we do that? Okay. So there is a wonderful plot which can give a lot of information about each and every variable. Okay. Um, that's called something called a box plot. Okay. So what we are trying to do here is make a box plot of variables. All right. So seaborn can be used to make a box plot. Okay. Um, as you can see, okay, so we have this is a pretty easy syntax. We have x, y, u, data. Okay. So you can read into the examples of how to get a box plot. Okay, but I'll start and just get one for you. The easiest way, if you have a data frame, is to just go on with box plot. Okay, and then pass in the data. Okay, it would automatically decide all the numerical, like the variables for which it can make box plots and do that for you. But here, as you can see, this is the number of Pokemons. This is the total HP. Then some of the features we actually want box plot for, and then generation and legendary. I don't think we need box plot for generation and legendary because these are technically not numerical variables. It made a box plot because it's essentially a Boolean 0 and 1. Okay, so as you can see, the values are also sort of in 0 to 1, like if it's near 0 to 1. Okay, so we'll get rid of the extra plots we have here, and we'll just use the iLog function for doing the same. So we want it for total HP, attack, special defense, defense, special attack, special defense, and speed. Okay. So this is 0th column, first column, second column, third column, fourth. So starting from fourth column, fourth, fifth, sixth, seventh, eighth, ninth, 10th, till 10th column. Okay, so till 11 we'd have to call. So we want all the rows and we want 4 to 10th column. All right. So let's go ahead and do that. Okay, so we have total HP, attack, defense, special defense, and speed. So total is definitely has a like has values which are greater than the others because total is the sum of all these. So for now, for understanding all these HP, attack, defense on a more granular level, so let me take total out of this plot. Okay. Yeah. So you will be able to see, yeah, you will be able to see better now the distribution of all these. Okay. And let's also increase the figure size. Okay, so you need to pass the figure size above this to so that it actually changes the size, otherwise it won't, as I told in the last video as well. Okay, so if you haven't watched the last video, I think it would be very beneficial for you to watch that both part 1 and 2, and I'll give the link of the same in the description. And also to get rid of this line we have, oh sorry, I'm not able to type today. Yeah, so we have this. Okay, yeah, so now we have these distribution of the various variables, and we can clearly see what the distribution is. Okay, so now let's try to understand how to read this box plot, which is one of the most important things. Yeah, so the bottom line, by bottom line, this means this line. Okay, this is the first quartile. Okay, so what does first quartile mean? The first quartile technically means that 25% of the data is in your variable is below this point. Okay, So this is essentially the number between with the smallest number you have and the median of the data set. Okay, so if you take the median, the sort of the middle number, and the minimum number, and you sort of see which number is exactly in between those. So this is 50% and this is the smallest, so you'll get sort of the 25%, the number below which 25% of the data lies. Okay, so this is represented by this line, this line, this line for all of these. Okay, and then we have middle line. By middle line I mean this. Okay, so this is Q2, which is the second quartile. Okay, so this basically represents that 50% of the data lies below this point. So 50% of the data is below this line. Okay, so 50% of the values are from like below this line. We have 50% of the data concentrated. Similarly, for this, we have 50% of the data below this line, this line, and this line, and this line. Okay. So similarly, we have top line, which here means the third quartile. Is a 75% of the data is essentially between, like below this line. Okay. 75% of the data in this variable is below this point. Okay. Yeah. You can also think about it as the middle value between median and the highest value. All right, I think that makes sense. Also, if you sort of subtract the Q3 minus Q1, you get the something called interquartile range. Okay, so what exactly is the use of this? You would sort of appreciate it more when we talk about how to get rid of outliers. But for now, okay, so let me give an introduction of this. Okay, so the upper end, when I talk about the upper end, I mean this line. Okay, and when I talk about the lower end, that means this line. Similarly, this line is the lower end, this line is the upper end, and similarly for every other variable as well. Okay, so this is basically the third quartile plus the 1.5 times of Q3 minus Q1 IQR. Interquartile range. Similarly, this is Q1 minus 1.5 times of the interquartile range. Okay, so technically what we do is that all the values which are above the upper end and below the lower end, okay, are basically treated as outliers. Okay, so they are they sort of represent the values which sort of are pretty different from like all the other values we have in the data set. So if we sort of use these values while doing the analysis, we might sort of have some bias in the model, which we don't really want. Okay, so we usually get rid of the outlier data. Okay, because these are special cases and not very general cases. Okay, so this is one important point to note for now, and we'll dig deeper into this as we move forward with the series and the analysis and data science. Okay. Yeah. So we can actually improve the aesthetics of this. We can get a title for this plot. So you can see how beautifully this basically sort of this box plot captures a lot of things in itself. Okay. So this is a beautiful way to see the variables and the distribution to understand the data better. Okay. All right. Okay. So let's move forward now. Okay. So we have what can we do next out of this? So let's try to understand. Okay. So we have mostly seen all the distribution of all these numerical variables. Let's try to see what sort of Pokemons are, which type of Pokemon essentially are legendary, like based on type 1. I'm not considering type 2 because there are a lot of missing values in type 2. So let's try to see like which Pokemons are legendary if we try to see by type, which type has sort of the greatest number of legendary Pokemons. Okay, so I think there is an easy way to show to see that. Okay, so instead of doing this first, okay, the better idea would be based on type. I think total would be a very good indicator of understanding if the Pokemon is legendary or not, because total is the total of all the good attributes that a Pokemon should or might have. Okay, so let's plot a bar plot for total based on type. Okay, so what do we want? Okay, so we want types, and then we want a bar plot which represents total. Okay, so let's try to look up the documentation. Do we have a good way to plot a bar plot using seaborn? Let's see. Okay, so this is pretty straightforward. sns.barplot, sns.barplot. Okay, and then we need to pass in vectors x and y, and yeah, but for x and y we need to understand what do we need to pass, because we want types here, and it's not that, like, we first want to group by type. Okay, so let's have our x as df dot group by. Okay, so we want to group by type 1, and then what do we want? We want the sum. What do we want? Okay, yeah, we want the sum. No, we want the mean actually. Sum would not make sense. Okay, so I'm commenting this for now because correct. All right, let's see what x looks like. We'll get to what we actually want. Okay, so we have this data frame wherein we have type, and then we have a number, total, HP, but we just wanted total. Okay, so what do we want? We just want total out of this. Okay, can we do an iLog on this? Sorry, a log on this. Something like, no, I think there would be a better way to do this. Okay, let's try. X dot log of x. Yeah, of x dot log x total. No, but we want, okay, we want we want to extract column. That would be an easier thing to do. 0, 1. So we want the first column, right? And we want all the rows. So let's write 1 to 2. Okay, let's see what we get. Okay, we printed this, so that's not something we want to do. We want to see what to, yeah, so we got this. Okay, so this is something we wanted from the start, right? So this is the variable essentially we want. So yeah, and then what do we want? Okay, so we want on one axis this type should show, and then on one axis the total column should show. Okay, so this is an index. Okay, so let's make a new row in this y data frame we have. Okay, so this is how we sort of make a new row in the data frame, and we can extract the index of this by just writing y.index, and yes, and then we'll print y again and see what happened actually. Okay, so now this index is now a column. Okay, essentially in this data frame. Okay, we did this because for ease, because we wanted to pass this total and index. So now we have what we want to do here. Okay, so for bar plot, what do we need? What do we need? Okay, so we have x and y, and then we want to pass the data. Okay, you can see the examples again if you feel stuck. Okay, so if you see this example, sns.barplot, they're passing x and y from the data frame itself, and then giving the data name. Okay, so we would follow the same thing. Okay, so what is the x we have here? So they had x as days. Okay, we have x as type 1, sorry, total, and then sorry, we want x as something which is not numeric. Okay, and then y as something that's numeric. Okay, so that's total. Okay, oh sorry, I think even the like without double quotes it should work, but I want to take any chance in this. We'll have to type again. What's the point? So the data frame is wrong. Data frame is why, not this. Okay, so be sure you get the right thing. Okay, so let's comment this out because we don't want this now. Okay, so we have this data frame, but the problem with this is that we are not able to read the types of yeah. So what we can do is, okay, so there is something called, I think it's Orient. Yeah, we can change the orientation of make it horizontal rather than vertical. Okay, so what would happen is that this whole plot would sort of rotate, okay, so that we are able to read these names. So what would happen is that the y and x would have to flip for that because we are rotating this. Okay, you'll get what I'm trying to say in a second. Orient equals, we want h. Okay, I think, oh sorry, that should come in practice quotes. Yeah, okay, now we are able to read this. That's great. And then let's go for pld.show and get rid of this line. And also let's increase the size of the figure. Fig size equals 10 comma 10 comma 10, my favorite size. Yeah, okay, so we have the total, and then we have the index, which is supposedly we don't want index to be written here, but rather we can change the label of the y-axis. Okay, we want type of Pokemon written here instead. Okay, so we can get that. Yep, so now this change to type of Pokemon, and then we have total. Okay, so the total is the greatest for dragon type of Pokemons. Okay, so okay, so if that's the case, can we also check if the dragon type of Pokemon are the ones which are like the most number of legendary Pokemons in our list are of type 1 as dragon? Okay, so this is the next thing which we can sort of check. Okay, so let's filter out and make a new data frame in which we have, okay, we use the log function. I hope you are understanding the log function because we have used it a couple of times now. If not, then you can check out the previous videos. That would help a lot. So let's sort of filter out based on the legendary Pokemons, and then let's view our data frame. Okay, so now we have only the legendary Pokemons. All right, so what do we want to do is, why did I do this filter is basically I want to see that which of the Pokemon are legendary and then group by type. Okay, to see if dragon type are actually the Pokemon which are like mostly the legendary ones. Okay, so let's try this. Okay, so on the new underscore df, what I can do is I can group by type. Okay, I can group by type 1. Okay, and then let's name it as new underscore df2. Okay, and okay, get rid of extra spaces and then print new underscore df2. Okay, oh sorry, I want to take a mean. No, I want to take a sum because I want to count. Okay, yep, sorry. Okay, but yeah, this is fine actually, but I want only the count of the legendary. Okay, based on type. Okay, so let's filter out the legendary column out of this. We know how to filter a column out of the data frame. Okay, so I could have also written it as I'll show you in a second. Okay, instead of taking legendary here, what I could have done is, so we have a data frame called new underscore df2. Okay, yeah, so we have this. We don't even need this actually. Yeah, so we have underscore new underscore df2. Okay, so out of this we wanted legendary. Okay, sorry, legendary. Okay, so we got this. Oh, right. Now you get, so I'm getting a row out of this. Okay, so rather than calling it as separately, what I did was that I just sort of put it here itself. Okay, now we have this. So now we notice that the type 1 for this is basically the number of legendary Pokemons is highest for psychic. So most of the legendary Pokemons are psychic. And the second is dragon. Okay, so it's not what we were trying to estimate out of this. So we had total highest for dragon. However, the more number of legendary Pokemons are in psychic. Though we can clearly see that dragon is also at the second like position here. Okay, we can sort these values actually. That would help to understand, because these are pretty low number of values, but if they were like a lot of values, then it would have been a problem to view all the values here. Okay, so that's the reason I'm sorry. Okay, so now we can clearly see that psychic is on the first and then dragon is on the second, and fairy Pokemons, as the name suggests, they are not apparently they are not very legendary. Okay, yeah, so this is one of the things that was there. Okay, so the next thing which we can explore is that so we have some legendary Pokemons, right? So what is the what is the most important characteristic for a Pokemon to be legendary? Is it HP being high, which leads to a Pokemon being legendary, or attack being high, which leads to a Pokemon, or defense being legendary, or a defense or special attack, or stuff like that? Okay, so what we can do is we have a data frame which has only legendary Pokemons, which is new underscore df. Okay, so from new underscore, let's print that out once again. Okay, so from new underscore df, what we can do is we can take the maybe the mean of, okay, mean of some columns like this. Sorry, we can take mean of this 0, 1, 2, 3, 4, 5th, fifth column, 6th, 7th, 8th, 9th, 10th till 10th. Okay, so we need all the rows, and then we need 5 to 11 columns, and then we need to take a mean. Okay, okay, all right. So in these are only the legendary Pokemons we were considering. So in the legendary Pokemons, what we have is that attack is the most important, no sorry, special attack is the most important characteristic. Okay, the mean of special attack is highest. We can actually sort these values again. Sort underscore values ascending equals false. All right, okay, so special attack seems to be one of the most important characteristics to understand like the which sort of decides if the Pokemon will be legendary or not. Okay, we can also take the median, because this can be biased, because we had some outliers as we noticed in the box plots. So let's also try the median. Okay, you'll appreciate it more why I prefer median. Like if you think about it, because median is sort of the center, and mean is not sensitive to mean is sensitive to the outliers, but median is not sensitive to the outliers. Okay, yeah, so here as well, okay, as we see, special attack and attack are the two important characteristics which sort of determine like the the Pokemon being legendary. Okay, so these are, if I had to guess a characteristic which, so supposedly somebody told me that there's a legendary Pokemon. Okay, so what do you think what would the characteristic of a legendary Pokemon would be? So my best guess would be that the attack of that Pokemon or the special attack of the Pokemon is gonna be pretty high. Okay, uh, but okay, so what, there is one more thing. Okay, to understand, we also need to see in general if this is high. Okay, or is it just the case for legendary Pokemons. Okay, so what we can do is we can sort of filter based on Pokemons not being legendary. Okay, so we can go ahead and do that as well. Legendary, sorry, equal to false. Okay, and then this is non-DF. Okay, this is non-legendary Pokemons wala DF. Okay, so we go ahead and print that out. Okay, there's some key error. What did I mess up? Okay, sorry. Yep, now that sorry, that's an extra that. Okay, now that should work out. Yep, so we have all the Pokemon which are not legendary. Okay, so now let's do that same thing here. So instead of this, we just need non-DF and see the mean. Okay, so what we see is that attack is the most important characteristic here, and let's also take the median actually. So attack is the non-DF. Okay, I need to change median. Okay, so attack is the most important feature, still the most important feature, even in the non-legendary Pokemon. So it's in general high for the Pokemons we have got, but special attack is not pretty high. Okay, so I would say special attack is like somewhat of a more important feature in deciding if a Pokemon is legendary or not, based on the data set we have. Okay, so I think you get the idea of how to go about thinking about the data, and it's more about how you can analyze and understand and think about various scenarios, rather than just just going ahead and like plotting the graphs. Okay, so you also, the important thing in data analysis is to think about stuff and get insights out of it. Okay, so that's what I wanted to show out of this analysis, that you need to start thinking about things rather than just trying to code stuff. Okay, so for this video I think we are past the time, and we'll continue with more cool stuff in the future videos. Okay, so stay tuned, like, share and subscribe if you like my content and if it helps you in some way. Okay, thank you, have a great day.